It's now been only days since 3i Atlas cleared Perihelion, the closest point in its orbit to the Sun, and the data coming in tonight does not align with any of the models built before that encounter. Observatories across both hemispheres are reporting readings that, for lack of a better word, don't fit. Its brightness curve has flattened when it should have spiked. Its velocity appears marginally reduced instead of increased, and the first post-perihelion optical traces place it a few arcseconds off its projected path. Small, but significant enough to force recalibration of every predictive map made since last year. Teams from Mauna Kea, Atacama and La Palma are running cross-checks as you hear this. Preliminary analysis shows a pattern forming, a recurring discrepancy that doesn't follow thermal outgassing, solar drag, or any known post-perihelion dynamic. It's as if the object absorbed energy near the Sun, and is now redistributing it internally rather than radiating it outward. No one expected this level of deviation, especially after such a clean inbound trajectory. But the anomaly isn't limited to position or brightness. New telemetry hints that 3i Atlas may have undergone a physical phase change, something in its structure or spin that redefined its reflective surface. If true, the shift would mean this object is not just continuing its journey outward, it's behaving as if it just transitioned into a new operational mode. And that's where the investigation begins, because the first data frame after perihelion tells a story none of us were ready for. For nearly 72 hours after perihelion, 3i Atlas was invisible, swallowed by the blinding solar glare. Astronomers expected that. What they didn't expect was how it would return. When the first detection came through from the Solar Terrestrial Relations Observatory feed, it was faint, weaker than predicted by almost 40%. At first, analysts blamed residual solar interference, but when the European Southern Observatory confirmed the same dim signature from a different angle, the conversation shifted. The models hadn't just been slightly off, they were obsolete. Its coordinates placed it a fraction of a degree lower than forecasted, a margin small enough to ignore in most cometary studies, yet here it mattered. Because 3i Atlas isn't an ordinary interstellar fragment. Its entire inbound trajectory was modelled with precision down to the minute. Deviations this size shouldn't exist unless something altered its course. The initial thought was gravitational nudging, perhaps by the Sun's complex magnetic field near perihelion. But the math doesn't hold. The delta vector suggests a push, not a pull, as if the object changed direction intentionally. At the same time, something strange is happening with its light. Instead of the sharp, reflective peak scientists anticipated after the close solar pass, its magnitude graph is erratic, fluctuating in intervals too regular to be random, yet too faint to match known rotational light curves. Every 6 hours, a minor dip. Every 12, a sharp increase. It's as though the object is alternating between reflective and absorptive states. And that's not normal behaviour for a passive body in space. Across observatories, the tone of discussion is shifting from confidence to cautious disbelief. No one is claiming propulsion, not officially, but the word appears in internal threads from multiple research teams. Directional bias, momentum correction, non-gravitational influence. Each phrase avoids the core implication, but all hint toward the same thing. 3i Atlas might not be drifting anymore, it might be navigating. Meanwhile, thermal readings show a drop, not a spike. Instruments tuned to detect post-solar heating found the infrared emission lower than pre-perihelion baselines. The surface, whatever it's made of, didn't heat as expected during its close approach, it cooled. That's physically backward. When an object skims past the Sun, its outer layers should vaporize or at least outgas. But 3i Atlas remains cold, stable, and strangely opaque to thermal analysis. It's as if it carried an internal insulation layer or redirected heat inward rather than releasing it. Radio observatories monitoring the reappearance detected something else. Faint, narrow-band spikes that repeat with near-perfect periodicity. Initially dismissed as instrument noise, the pulses align exactly with the object's rotational cycle, suggesting they're not random. Each pulse lasts less than a second, just long enough to register as a consistent spectral anomaly. The frequency is too high for standard cosmic rays and too clean for magnetic interference. The implication is unsettling. Either 3i Atlas is emitting, or it's reflecting a signal from an unknown source. Inside the data review rooms, the silence is palpable. Scientists are cautious not to jump to conclusions, but the private logs show it clearly. No one has seen a pattern like this since Oumuamua. And even that object, as strange as it was, didn't produce synchronized emissions. By now, teams at Harvard, JPL, and the European Space Agency are rerunning trajectory predictions with the new coordinates. The path no longer matches a simple hyperbolic escape. Instead, the outbound leg curves slightly, subtly, as though guided by a faint additional force. The effect could be explained by asymmetric outgassing, but no gas jets have been detected. The dust signature is almost non-existent. That's another problem. There's no visible coma, no debris trail, no indication of sublimation. A comet that close to the Sun should be surrounded by a glowing halo of material. Yet 3I Atlas remains clean, sharp-edged, and dark. Some are calling it the quietest comet in recorded observation. Others say it's no comet at all. At Mauna Kea, one of the high-resolution telescopes captured a blurred but revealing silhouette. The elongated shape remains, roughly 400 meters in length, but the proportions seem slightly altered. The leading edge, once described as irregular, now appears smoother, as if erosion or melting reshaped it during perihelion. However, that theory fails when confronted with its thermal readings. It didn't melt, it adapted. There's speculation that part of its surface changed albedo intentionally, that the reflective patches visible pre-perihelion are gone because the object darkened itself, perhaps as a passive cooling mechanism. Metallic asteroids can oxidize, yes, but not uniformly, and certainly not in a way that creates symmetrical reflectivity cycles. The modulation we're seeing is too consistent, too deliberate. Astronomers watching the light curve over time notice something else. The rhythm of its brightness pulses matches the 6-hour rotational period measured months ago. But now, the pattern is inverted. The dimmest points correspond to what used to be the brightest side. It's as if the object flipped its axis or altered its orientation relative to the Sun. Either way, the old models no longer apply. In scientific briefings, terms like reflective modulation and rotational damping appear frequently. They sound neutral, but behind those words is quiet confusion. How does a tumbling interstellar object suddenly stabilize itself? How does it suppress heating, reduce outgassing, and maintain coherence after a solar encounter that should have torn it apart? The answer, so far, is that no one knows. But a growing number of researchers are considering one radical explanation, that the object anticipated perihelion and prepared for it. If that's true, then 3I Atlas isn't reacting to its environment, it's managing it. Data coming from the Deep Space Network suggests that after its brief period of dim reappearance, the object's trajectory adjusted slightly, now aligning toward a vector offset by 0.04 degrees from its predicted outbound path. It's a minor deviation, but when projected over millions of kilometers, it translates into a significant directional shift, one that cannot be explained by random outgassing or solar wind drag. The change is steady, not impulsive. It's as though the force behind it is continuous, controlled, and faintly accelerating. In one closed meeting transcript, a researcher from the European Space Operations Centre summarised it in a single line. "We are not tracking an inert mass, we're tracking a behaviour. Right now, several independent teams are working to confirm or refute that claim. The next few observation windows will determine whether this is a measurement artefact or the beginning of an entirely new phase in the object's evolution. For now, all anyone can say with confidence is that 3I Atlas has reappeared, dimmer, colder, and slightly off course. Its silence, both visual and spectral, feels deliberate. The data suggests internal order where randomness should reign." The first orbital recalculations arrived early this morning, when the Harvard-Smithsonian Center for Astrophysics combined data from Atacama, La Palma, and Pan-STARRS. The results were consistent, but unnerving. 3I Atlas isn't following a clean escape trajectory. Its motion shows a measurable curvature that doesn't fit with gravitational predictions. Not a random drift or instrumental error, but a persistent directional offset, a deviation that grows larger with each update. The numbers aren't huge yet. The arc difference is less than 1/10 of a degree. But it's accelerating, and that's the part that has everyone on edge. If this were a natural comet, the explanation would be straightforward. After perihelion, outgassing from sunlight heating the surface often pushes small bodies off course. But there's a pattern here that doesn't match any recorded comet in the databases. Instead of erratic thrusts caused by venting gas, the force on 3I Atlas appears constant, a uniform push that gently shifts its path outward in a smooth curve. Almost as if it's being guided along a controlled vector rather than flung by chance. The team at Caltech modelled possible explanations. A gravitational assist from the Sun's complex magneto-hydrodynamic field? Too weak. Solar radiation pressure? Not enough momentum. Outgassing from hidden jets? Would cause random wobbling, not precision alignment. And yet the drift continues. Perfectly stable, almost elegant. The simplest term to describe it is non-gravitational acceleration. But that phrase has become a code among astronomers for something more complicated. An influence we can't yet categorize. Simulations project that if the current drift continues, 3I Atlas will intersect a slightly different orbital plane by mid-November. That path threads uncomfortably close to the inner solar observation satellites stationed near Earth's line of sight. In other words, its motion isn't just unexpected, it's heading into a corridor filled with sensors, telescopes and transmitters. If this is coincidence, it's a precise one. The phenomenon has forced a rare collaboration between rival institutions. NASA's Jet Propulsion Laboratory, the European Space Agency, and the Japanese Hayabusa mission network are pooling data to form a joint analysis stream. The live plots reveal another subtle anomaly, a secondary oscillation in its light curve that hints at microvariations in speed, microbursts of acceleration and deceleration over time. The fluctuations are so fine they're nearly invisible, but they repeat at exact intervals of 22 minutes. No known physical process would produce that timing naturally in an object of this mass and density. It's also worth noting that these oscillations coincide with the narrowband radio spikes recorded 2 days ago. That temporal overlap could be coincidence, but statistically it's improbable. Each 22-minute pulse aligns within seconds of the object's faint electromagnetic emissions, as if the two phenomena are connected. The pattern has triggered comparisons to spacecraft telemetry sequences, controlled bursts, pauses, recalibrations, except this source sits millions of kilometers from any transmitter we know. Astronomers are split between two camps. The conservative side insists on natural explanations, asymmetric reflection, rotation-induced drag, or internal stress fractures altering its shape. The others, more cautious but less skeptical, admit that those mechanisms don't fully explain the coherence of the drift. Some even speculate that we might be witnessing a type of self-stabilizing motion, as though 3I Atlas is correcting its own trajectory in response to solar interference. At the University of Cambridge, an internal memo circulated this afternoon outlining a theory no one wanted to publish yet, the dimensional drag hypothesis. It proposes that 3I Atlas might be interacting with an external field, possibly electromagnetic, possibly gravitational, that doesn't behave in three-dimensional space the way we expect. In simpler terms, the object could be following a geometry we can't yet visualize. Not faster than light travel, not exotic propulsion, but a subtle manipulation of how momentum transfers through space near high-energy boundaries like perihelion. The memo suggests that the smoothness of the drift, its continuous acceleration, and the synchronization with radio spikes might point to a controlled resonance effect, a deliberate alignment with solar magnetic flux lines. It's a bold claim. Most astrophysicists dismiss it outright, calling it speculative at best. But even those critics admit one uncomfortable truth: the data doesn't rule it out. A quiet tension has settled over observatories. Every hour brings new readings, and with each update the object's predicted position slides further from the models. Instruments recalibrate, tracking software adjusts, and the drift continues, like a slow-motion maneuver no one authorized. There's also a new visual oddity. The Hubble Space Telescope's first post-perihelion images show an extremely faint diffuse glow extending from the object's trailing edge. It's not a dust tail, it doesn't expand outward or scatter light in a normal way. Instead, it's narrow, almost like a filament. The emission appears to fluctuate with the same 22-minute rhythm seen in the radio data. The simplest explanation would be thermal venting, but that fails under infrared scrutiny. The glow emits no detectable heat. It's purely optical. In layman's terms, something is shining, or resonating, without producing measurable warmth. Meanwhile, computer models attempting to backtrack the drift's source point to one specific event, the moment of perihelion. At that instant, 3I Atlas experienced the strongest gravitational and magnetic forces of its journey. If it carried even minimal internal structure, metallic veins, hollow cavities, or conductive networks, those could have induced electrical currents strong enough to alter its spin or even trigger internal realignments. In essence, the Sun might have activated something dormant inside it. That possibility has reignited debates that seemed long settled. When the object was first detected in early 2025, skeptics compared it to natural interstellar debris. But as each anomaly stacks up, the brightness modulation, the thermal inversion, the controlled drift, the boundary between natural and engineered blurs. No one is ready to cross that line publicly, but behind closed doors the tone is shifting. The latest joint report from ESA's Near-Earth Object Coordination Center ends with an uncharacteristically vague statement. Observed, non-gravitational influences persist beyond expected parameters. Further monitoring required. That's diplomatic language for, we don't know what's happening. Over the next 24 hours, the object will enter a clearer observational window, giving ground-based telescopes their best chance yet to verify the drift in real time. If the pattern holds, by tomorrow, 3I Atlas's course will have diverged far enough to confirm an active force. Something intrinsic, continuous and unexplained. For now, all analysts can do is keep watching. The drift is steady. The radio pulses continue, and the object, silent as ever, glides through the dark. No outgassing, no noise, just motion that feels deliberate. The next phase will determine whether this is a quirk of celestial mechanics or the first trace of control we've ever seen from something not of this solar system. As the new photometric data streams in from observatories across 3 continents, one thing becomes clear: 3I Atlas isn't reflecting sunlight the way it should. Its albedo, the measure of how much light it bounces back, is oscillating in a pattern that defies every known physical explanation for an inert body. The brightness doesn't fluctuate randomly, it pulses. Every 8 hours, the light curve dips, holds for roughly 90 minutes, then rises again to nearly double its baseline intensity. And this isn't a measurement error. The same rhythm has been independently confirmed by the Subaru telescope in Hawaii, the Very Large Telescope in Chile, and the Hubble Space Telescope. In astrophysics, brightness variations usually tell a simple story: rotation. As a tumbling body spins, its irregular surface reflects light unevenly, producing predictable peaks and troughs. But the pattern emerging from 3I Atlas is too clean, too structured, almost mechanical. The amplitude of each pulse remains consistent down to the 4th decimal place, like a metronome ticking in deep space. It's not tumbling chaotically, it's rotating with intention. At first, scientists theorized that the fluctuations might be caused by surface ice sublimating and refreezing, the standard explanation for cometary brightness changes. Yet infrared readings still show an impossible contradiction. The surface remains cold, nearly inert, and devoid of outgassing. No dust, no vapor, no material movement. In short, nothing that should cause its reflectivity to oscillate. The object appears to be modulating its own visibility. The question haunting every control room tonight is simple but unprecedented. Can an object decide how bright it wants to be? A preliminary report from the ESA Optical Tracking Division notes a peculiar alignment. Every brightness surge coincides with the exact moment the object's trajectory brings it closest to the Sun's magnetic field lines at its current orbital position. When it crosses those regions, reflectivity increases sharply, almost as if the object is responding to changes in electromagnetic flux. If that's true, 3I Atlas isn't just reacting to sunlight, it's interacting with the solar environment in a way no natural object should be capable of. The team at Harvard is calling this phenomenon photometric modulation. They hesitate to use stronger words, but the implication lingers. 3I Atlas could be manipulating how it appears to us, not because it emits its own light, but because it's adjusting its reflective geometry. That means it might possess some degree of active surface control, either through rotation stabilization or through microstructural reconfiguration. High-resolution imagery supports this. Comparing pre- and post-perihelion captures reveals subtle but undeniable changes in surface reflectance patterns. Before perihelion, light scatter was diffuse, typical of rock and dust. Now, it's sharply directional, concentrated along specific angles. a characteristic often seen in engineered materials like polished alloys or adaptive composites. Natural rock simply doesn't behave like that. Some scientists suggest an explanation that's both conservative and disturbing: phase change materials. In this theory, the surface of 3I Atlas could contain compounds that shift between reflective and absorptive states depending on local magnetic flux density. That would explain the synchronized brightness pulses, and it would imply an advanced understanding of energy regulation, possibly built for survival near stars. However, there's another hypothesis emerging, one that's even harder to dismiss. A small group within NASA's Planetary Science Division points out that these light modulations resemble active signaling. Not communication in the conventional sense, but a mathematical rhythm, a binary-like pulse sequence too regular to be random noise. The pattern holds steady over time, but occasionally introduces minute variations in amplitude, forming what looks like encoded data. When converted into frequency intervals, those variations align with prime number sequences 2, 3, 5, 7, 11. That correlation could be coincidence, but if it isn't, then something extraordinary is happening. Publicly, no one mentions this. Official press releases remain cautious, repeating phrases like optical variability and possible reflective interference. But leaked transcripts from internal briefings reveal a more unsettled tone. One scientist described the object's brightness curve as structured, not stochastic. Another simply said, "It's blinking back." The uncertainty is starting to fracture the scientific community. Some claim confirmation bias, that researchers are seeing patterns because they want to. Others argue that the data is too consistent to dismiss. Even among skeptics, a quiet acknowledgement is spreading. If this were purely natural, we'd have seen something like it before. Meanwhile, observatories continue recording, and the pulses remain steady. The precision of the intervals, 8 hours between surges, 90-minute hold periods, has remained unchanged for 4 consecutive days. That constancy is what breaks most natural explanations. In space, chaos dominates. Dust, gravity, radiation pressure, everything introduces randomness. But 3I Atlas behaves like a system running on internal order. Spectroscopic analysis adds another layer. During each brightness surge, the object's reflected light briefly shifts toward the ultraviolet spectrum. That's unusual. UV reflectivity typically requires highly smooth or ionized surfaces. For an interstellar body to produce that effect naturally, it would need to be coated with metallic compounds not yet observed on comets or asteroids. Some samples from the analysis suggest traces of nickel, iron, and an unknown element with absorption bands near 390 nanometers, a wavelength region associated with synthetic alloys. If confirmed, that would mean 3I Atlas isn't just a rock, it's something constructed. The possibility hangs in the air, unspoken in official channels but repeated quietly in every late-night conference call. What if the object is controlling its albedo to regulate temperature? Or worse, to send information? The Deep Space Network has begun continuous monitoring to look for repeating photometric codes. So far, nothing definitive, but the raw data shows an unmistakable rhythm, one that doesn't degrade with distance or solar interference. That implies a stable internal process, not decay, not chaos, but persistence. Outside the scientific community, media outlets are starting to notice the silence. The same object that captivated the public during its inbound approach has now gone quiet in headlines. Only a few investigative science journalists are still tracking it, and they're beginning to ask uncomfortable questions. Why are so many observatories refusing to release full brightness data? Why are certain orbital records now classified under restricted monitoring? For the researchers still watching, the concern isn't media coverage, it's what comes next. If the brightness pulses intensify, the object's internal energy distribution could change. That might alter its trajectory again, accelerating the drift noted earlier. And if those light variations are intentional, the next phase might involve more than reflection. The next 48 hours will be critical. Ground-based instruments will align to observe the object's next light surge. If the pulse sequence holds its prime number rhythm, it will officially cross the statistical threshold for randomness. At that point, the term anomaly will no longer suffice. Right now, the consensus is cautious. No one is calling it artificial. But no one can explain why, after passing perihelion and surviving the sun's heat, 3I Atlas continues to blink, rhythmically, deliberately, like something that knows it's being watched. The latest infrared readings from NASA's NEOWISE and ESA's solar orbiter have confirmed what many researchers suspected. 3I Atlas is cooling, not just stabilizing after perihelion, but actively losing heat faster than any known interstellar object of comparable size and composition should. Its thermal signature has declined by nearly 20% in less than 48 hours, even as it moves into regions of space still saturated with residual solar radiation. That makes no sense. The sun's influence should be keeping its surface warm for weeks. Instead, it's plunging towards subthermal equilibrium, as if something inside it is drawing energy inward. To understand why this is so strange, consider how typical objects behave after perihelion. When a comet swings close to the sun, its frozen gases boil off, forming a coma and tail while the surface radiates leftover heat. Even metallic asteroids stay warm for days due to absorbed solar energy. But 3I Atlas doesn't fit that rule. Its infrared emissions dropped sharply just hours after re-emerging from behind the sun, a behaviour completely opposite to what the laws of thermodynamics predict. At first, analysts thought the anomaly could be an observational artefact, perhaps a calibration mismatch between instruments. But when data from Japan's Akari telescope matched the same cooling curve, the error hypothesis fell apart. The object's temperature isn't being misread, it's genuinely declining. That leaves only two explanations. Either 3I Atlas has an extremely high thermal conductivity, allowing it to distribute and dissipate heat rapidly across its structure, or it's redirecting that heat internally. Both possibilities raise new questions. If the material is hyperconductive, it must be composed of alloys or crystalline structures unknown in natural astrophysics. And if it's redirecting heat inward, that implies organization, the thermal management system, not a random property. A senior physicist at MIT's Haystack Observatory summarized it bluntly during a closed-door meeting. Either it's made of something we've never encountered, or it's doing something we've never seen. That statement captures the mood tonight in nearly every research centre monitoring this object. Scientists are beginning to use words like containment and regulation, not typical language for a rock in space. The cooling appears targeted. The regions that should retain the most heat, the sun-facing edges, are dropping faster than shaded areas. It's as though those surfaces are actively shedding radiation, while the interior remains stable. Thermal maps from the solar orbiter show a striking detail. The cooling doesn't occur uniformly. 3 distinct nodes along the object's length exhibit pulsing temperature gradients, cold spots that deepen and fade in a repeating rhythm. Each pulse lasts precisely 12 minutes. That repetition has triggered speculation that the object might possess internal chambers, or structures cycling between active and dormant states. No natural object should have temperature oscillations that precise. One theory, gaining quiet traction, suggests electromagnetic refrigeration, a process by which materials manipulate magnetic fields to absorb and redistribute heat. In laboratory conditions, it requires advanced control and energy input. Yet the thermal pattern on 3I Atlas mirrors that behaviour perfectly. If this mechanism is active, then the object might be using the sun's energy not for propulsion, but for stabilization, cooling itself intentionally to preserve structural integrity after perihelion exposure. Another group at the Max Planck Institute has proposed a different angle. They've identified faint emissions of low-frequency radiation that spike each time a temperature pulse begins. These emissions resemble the kind produced by superconducting transitions, moments when conductive materials suddenly change states. The implication is staggering. 3I Atlas may contain materials that become superconductive under cosmic conditions, storing energy rather than dissipating it. Still, not everyone agrees. Some argue for a purely natural explanation. Internal cavities filled with volatile compounds could be absorbing heat through phase transitions. But the absence of any outgassing undermines that argument. If sublimation were occurring, we'd see expelled matter, jets, dust, or vapor trails. Instead, 3I Atlas remains pristine. The only evidence of activity is invisible, thermal and electromagnetic. What's particularly unsettling is the timing. The onset of cooling began almost exactly when the brightness pulses intensified. That overlap suggests a coordinated process. When its light increases, its temperature drops. When brightness fades, the surface warms slightly. The two variables move inversely, like a machine managing input and output energy in balance. Natural systems don't coordinate feedback loops like that. Within the international observation community, this correlation has forced a reluctant re-evaluation of assumptions. Some scientists now speak privately about energy regulation behaviour, the possibility that 3I Atlas functions as a self-contained thermal system. If true, it means the object doesn't merely endure solar exposure, it interacts with it, transforming energy from one form to another. A leaked section of the Harvard-Smithsonian's internal report goes further. It posits that during perihelion, intense solar radiation might have triggered a reactivation event, perhaps awakening dormant mechanisms embedded within the object. The report stops short of using the word artificial, but its phrasing leaves little doubt. The coordinated timing between optical modulation and thermal inversion suggests an energy distribution process inconsistent with natural thermodynamics. Right now, every attempt to explain the drop through classical astrophysics fails. Even deep metallic composition models don't predict such efficient heat loss. The only environments known to produce this level of cooling are engineered systems designed for cryogenic regulation, technologies meant to protect internal components from extreme heat. At the European Southern Observatory, a small team ran simulations to test how long the trend could continue. If the cooling persists at its current rate, 3I Atlas will reach near background cosmic temperature within 9 days, colder than space objects that have drifted for centuries. That rapid equalization could mean one of two things. Either the object is entering a dormant state, or it's preparing for something that requires extremely low thermal output, perhaps stealth or conservation. Some analysts even whisper about the possibility of phase cloaking, a phenomenon where a body reduces its infrared signature to near zero, effectively becoming invisible to heat-detecting instruments. While speculative, that concept fits the data more closely than any cometry model. The implications are unsettling. If 3I Atlas is deliberately reducing its thermal footprint, it's not just adapting to its environment, it's concealing itself within it. For now, every telescope capable of measuring infrared is trained on its coordinates. Each new dataset is both exciting and frustrating. The object continues to cool, the pulses remain rhythmic, and no natural model yet fits. Some scientists are calling for calm, urging patience until the next solar rotation gives better observation angles. But a growing number admit privately that they've never seen an interstellar body act with this level of precision. The phrase appearing in one recent classified document captures the unease perfectly. Post-perihelion thermal behaviour suggests intentional regulation. If that statement proves true, then 3I Atlas may not just be drifting anymore. It may be stabilising, preparing for whatever comes next in its outbound trajectory. As 3I Atlas moves farther from the Sun, astronomers expected it to be wrapped in a bright reflective haze, a cloud of dust left behind by vaporized material. Every comet does this after perihelion, but this one doesn't. It's clean, silent, and perfectly intact. Instruments from the Solar and Heliospheric Observatory report almost no particles in its wake. The area around it is as empty as open space. That shouldn't be possible. Any object that close to the Sun should be shedding matter, releasing gas and fragments as it cools. Instead, 3I Atlas remains solid and sharp, its surface showing no signs of erosion or outgassing. It didn't melt, it didn't break, it simply kept moving, untouched. The first theory was that it isn't made of ice at all, but of dense metals or silicates, something closer to an asteroid than a comet. But even that explanation collapses when you look at the data. Metals can't survive a solar pass without heating, expanding and fragmenting, yet its mass has barely changed. The object seems immune to the sun's radiation. That's when researchers began to notice something even stranger. Around the object, light behaves differently. There's no scattered dust, but there is a faint optical distortion, a kind of invisible boundary. Some think it could be a charged plasma layer, a field strong enough to deflect solar particles before they touch the surface. Natural objects don't generate fields like that. Readings from the Parker Solar Probe support the idea. As it passed near 3I Atlas's path, its sensors recorded a drop in solar wind density, a small pocket of calm where there should have been turbulence. It's as if the object created a bubble around itself, repelling charged particles the same way Earth's magnetic field shields us from radiation. Officially, NASA calls this an unexplained environmental anomaly, But inside the data teams, no one's satisfied with that label. Some quietly describe it as a form of shielding, not active in the technological sense, but controlled enough to preserve the object's surface perfectly intact. Meanwhile, polarimetric studies from ground telescopes show a halo of polarized light around it, suggesting organized electromagnetic activity. In plain language, that means the space immediately surrounding 3I Atlas isn't just empty vacuum, it's structured. Something is shaping the light as it passes by. That's not how inert rocks behave, that's how systems behave. A few scientists now think the object may have built up a massive static charge during its solar pass, strong enough to form a protective layer. But electrostatic charge usually bleeds off within hours under solar conditions. This one hasn't faded. It's holding steady day after day as though maintained deliberately. The absence of dust has another side effect. It makes 3I Atlas incredibly hard to see. Without reflective debris, telescopes relying on scattered light can barely track it. On some nights, it seems to vanish completely between exposures, as if it's dimming itself from specific wavelengths. Because of that, radar is now the only reliable way to locate it. Those radar echoes reveal more. The reflections are unnaturally sharp, cleaner than any rock or metal fragment should produce. Some signals even return in staggered bursts, like different parts of the surface are responding at slightly different times. That's the kind of behaviour seen in structured materials, not random geology. At the European Space Agency, one analyst described the situation in plain terms. If the lack of dust is natural, we still have to explain how the object survived the sun's heat without eroding. But if it isn't natural, if it's something designed, then we have to ask why it hides its energy so precisely. Either way, both answers break what we understand about objects moving through this system. Over the last several nights, telescopes tracking 3I Atlas have detected something that's making researchers deeply uneasy. Its spin has stopped changing. The object, once tumbling irregularly on its inbound journey, now rotates with absolute stability. One axis, one rhythm, locked in place. That shift is more than unusual. It's nearly impossible without a significant external or internal influence. Before perihelion, 3I Atlas's light curve suggested a chaotic roll pattern, typical of elongated interstellar bodies. It rotated unevenly every 6 hours, sometimes drifting several degrees between observations. But since emerging from behind the sun, those fluctuations are gone. Every reading now points to the same rotational period, 6 hours, 0 deviation. The light peaks and troughs occur at the exact same time, frame after frame, no precession, no drift. To put that in perspective, most objects in space wobble slightly as they spin. Solar heating, micro-impacts and internal mass distribution all cause minor instability. Even artificial satellites require constant correction to maintain precise orientation. Yet 3I Atlas has achieved perfect balance on its own, as if it found a natural equilibrium, or something guided it toward one. Some scientists are calling this the rotational lock event. It marks a clear transition in the object's behaviour, a point where it stopped being governed purely by external forces. Theories are multiplying quickly. One group at the University of Arizona believes perihelion triggered a redistribution of mass inside the object, effectively shifting its centre of gravity. That could, in theory, stabilise rotation, but that process would take days or weeks, not happen suddenly in a matter of hours. Another hypothesis is electromagnetic coupling. As the object passed near the sun, immense magnetic fields may have interacted with conductive elements in its structure, aligning them like a compass needle. If 3I Atlas is even partially metallic, this could have synchronized its spin along the dominant field line. But that effect would fade as it moved away from the sun. Instead, the lock has become stronger. There's also a more unsettling possibility. If the rotation is not passive, if it's being controlled, then we may be observing an active stabilization system at work. The steady rhythm could be the signature of internal machinery maintaining attitude control. The repeating intervals of brightness and temperature pulses seen earlier now line up precisely with the object's rotation. It's as if each spin cycle is timed, regulated, and tuned to perfection. Infrared imaging supports that. 3 consistent hotspots appear along the surface, spaced evenly like points on a triad. They don't shift with sunlight. They move in unison with the rotation, maintaining exact relative positions. That symmetry suggests deliberate spacing, geometry, not randomness. Some astronomers interpret them as vent sites or electromagnetic nodes. Others say they could be structural stabilizers. Either way, the arrangement looks engineered. Radar echoes tell the same story. When pulses strike the object, they return with alternating intensity, bright, dim, bright, dim, as though certain surfaces are designed to absorb or deflect in rhythm with its spin. This creates a pattern of modulation that repeats every rotation. If this were natural, it would decay over time as energy dissipates. But it doesn't. The signal remains perfectly synchronized. The alignment itself raises an even bigger question: locked to what? Normally, a free-floating object aligns according to the forces around it: gravity, sunlight, or momentum. But 3I Atlas's axis doesn't match the plane of its orbit. It's tilted, pointing steadily toward a fixed coordinate near the ecliptic north. That orientation hasn't shifted since the lock began. Astronomers can't explain why. It's not following solar torque or any known gravitational reference. It's holding position like it's tracking something. At this point, speculation is turning toward control mechanisms. Internal mass movement, magnetic torquing, even rotational flywheels have been mentioned. Ideas normally reserved for spacecraft, not cosmic debris. Some suggest it might be harnessing the sun's magnetic field to maintain balance, converting electromagnetic energy into rotational stability. Others whisper about gyroscopic systems, ancient technology, maybe autonomous stabilization responding to solar intensity. The reality is simpler and stranger. The lock is too perfect. The timing between thermal pulses, radio spikes, and spin cycles has converged into one rhythm. A unified signal repeating every 6 hours. It's almost musical in its precision. You could set a clock to it. That's why agencies worldwide are now treating 3I Atlas as a dynamic target rather than a passive one. The Deep Space Network has shifted to high-frequency tracking, and new instruments are being recalibrated to monitor the 6-hour modulation directly. The hope is that if the pattern changes, it might reveal whether the object is reacting to something external, perhaps an incoming solar event or a nearby gravitational field. At the same time, new visual imagery shows subtle changes in surface brightness that match the rotation cycle. When one side faces the sun, reflectivity spikes briefly before dimming, almost like an adaptive material managing glare. Some researchers believe this might be part of a stabilization system, using controlled reflectivity to balance radiation pressure. If true, it would mean 3I Atlas is not just enduring the solar wind, it's using it. In internal communications, scientists are beginning to describe the object with different language. Not it, but its doing. Small words that reveal a shift in mindset. 3I Atlas is no longer treated as a drifting relic. It's behaving like a system that understands its own motion. One private comment from an ESA analyst captures the feeling in the room. It's not just spinning, it's holding position, like it knows where it's supposed to be. For now, all anyone can do is watch the data streams come in. The rotation remains steady, the radio pulses aligned, and the trajectory unchanged. But there's a growing sense that we've crossed a threshold. The object isn't reacting to the sun anymore. It's responding to something deeper, something we haven't yet detected. It started quietly, almost as a footnote in a data log. During a routine session at the Allen Telescope Array, researchers noticed a narrowband spike in the radio spectrum, sitting just above the natural background hum of the solar system. It was faint, barely distinguishable from static, but it repeated. Every 6 hours, like clockwork, the same signal appeared again, matching perfectly with 3I Atlas's rotational cycle. At first, it was written off as interference. The solar wind, terrestrial transmitters, even passing satellites can create false positives. But when the same pattern showed up in recordings from Jodrell Bank in the UK and from the Green Bank Observatory in the United States, the coincidence was no longer plausible. 3 instruments, on 3 different continents, all detected the same pulse, a whisper from deep space, synchronized with the spin of an object no one can fully explain. The signal isn't strong, it doesn't modulate in ways typical of communication or radar. It's steady, mathematical, and hauntingly precise, a narrow spike at 1420.405 MHz. That number matters. It's the hydrogen line, a frequency often used by scientists to search for interstellar signals, precisely because it's universal and naturally quiet. If anything intelligent were trying to send a message detectable across galaxies, this is the frequency they'd likely choose. When word of the alignment leaked through internal channels, observatories began verifying it independently. More data came in. The pulse wasn't constant, it had structure. Each burst lasted 0.9 seconds, then fell silent for exactly 359 seconds before repeating, a 6-minute loop nested within the 6-hour rotational rhythm. That kind of double synchronization is almost impossible to attribute to natural sources. By now, analysts are calling it spectral noise, a deliberately understated term meant to keep public attention away. Officially, it's categorized as a narrow-band emission of unknown origin. Unofficially, everyone monitoring the signal knows what it looks like. Intentional timing. Inside the Harvard-Smithsonian Astrophysical Data Lab, pattern recognition software has been running non-stop, searching for hidden structure. The results are ambiguous but strange. The gaps between the 6-minute pulses vary slightly, by milliseconds, forming a pattern that when graphed resembles prime number spacing, 2, 3, 5, 7, 11. The same mathematical sequence seen earlier in the brightness pulses. No one dares call it a transmission, but that's exactly how it behaves. If this were a natural emission, for example, magnetic flux discharges or rotational harmonics, the frequency should drift as the object's distance from the Sun increases, but it hasn't. The hydrogen line pulse remains locked at the same value, stable to 5 decimal places. That's better precision than most human-made transmitters achieve over interplanetary distances. The SETI Institute, usually cautious about extraordinary claims, has quietly moved a portion of its deep sky listening array toward 3 IATLAS's coordinates. They've confirmed the emissions but refused to speculate publicly. In private, one researcher summarized it this way: "We're not hearing a signal, we're hearing a process that distinction matters. A process suggests function, not intent. Activity without communication. It's possible that the radio bursts are byproducts of internal operations, magnetic cooling, charge regulation, or energy transfer. But even then, the precision is too deliberate to ignore. The emission intervals are not random noise, they're timed, repeating, and internally consistent." Another mystery lies in the polarization. The radio waves arriving from 3I Atlas are circularly polarized, spinning as they travel, a property rare in natural astrophysical emissions. Circular polarization typically arises when electromagnetic fields are intentionally oriented, such as in radar or telemetry systems. That's why the signal has become a dividing line among scientists. Some argue it's an artifact of reflection, perhaps bouncing from the object's surface as it rotates. Others think the polarization is intrinsic, a product of whatever process is happening inside. NASA's Deep Space Network began high-resolution analysis earlier this week, feeding real-time data into an experimental decoding program originally designed for satellite diagnostics. The program hasn't found a message, but it did reveal something else. The pulse waveform contains harmonics at predictable intervals, faint echoes that trail behind the main frequency like harmonized tones. Those harmonics fall within the same ratios found in engineered systems that use frequency layering, a technique for transmitting multiple channels within one band. In plain terms, the signal looks engineered, even if it isn't meant for us. The public hasn't heard about any of this yet. The information is confined to encrypted databases and internal academic networks, but word is spreading quietly among researchers. The same object that refused to heat, refused to erode, and now rotates with surgical precision is also emitting a pulse timed with that rotation. As more instruments lock onto it, the emission profile continues to evolve. Over the past 12 hours, a faint sideband has appeared, a secondary tone drifting upward by a few hertz before fading again. It could be interference, it could be a diagnostic signature, or it could mean the process is changing, recalibrating itself after perihelion, as though adapting to its new environment. For the teams observing, this development marks another threshold. It's one thing to watch an object defy thermal physics and orbital decay. It's another to hear it. The sound, if you convert the signal into audible frequencies, is a soft repeating hum, a heartbeat echoing through the void, unwavering and constant. Whether it's a natural resonance or a manufactured broadcast, no one knows. But as one scientist from the SETI array said during a midnight briefing, whatever it is, it's not silence anymore. Just before dawn UTC, A new trajectory update arrived from NASA's Jet Propulsion Laboratory. It shows something that shouldn't be happening. 3I Atlas is no longer following the smooth outbound arc predicted after perihelion. Instead, it's beginning to drift, not randomly, but with a steady curve like a controlled adjustment. The vector change is subtle, just a few arc-seconds off its expected course, yet the direction of that deviation tells the story. It's bending toward the ecliptic plane, the broad, invisible disk where the planets orbit the Sun, and by extension toward the inner system. For most comets, post-perihelion drift points outward, driven by residual outgassing as they shed their final dust. This one is doing the opposite. It's steering inward, cutting across the plane instead of away from it. The object isn't being pulled, it's pivoting. At first, mission analysts suspected a computational glitch. A single frame error in radar telemetry can cause apparent shifts in position, but multiple observatories, Goldstone, Arecibo, and even optical data from Atacama confirmed the same gradual deviation. Over a 36-hour window, 3I Atlas's path has curved by nearly 0.05 degrees. In cosmic terms, that's nothing. In orbital dynamics, it's enormous. Over the coming weeks, that small change could move it hundreds of thousands of kilometers off its projected path. The question now dominating every briefing is simple: what force is doing this? Solar radiation pressure was the first suspect, but calculations show it's too weak to account for the consistent acceleration. The drift doesn't fluctuate with solar intensity, it increases steadily, unaffected by the drop in photon flux as the object moves farther from the Sun. That rules out sunlight as the driver. Next came the idea of asymmetric outgassing, a jet of vapour from one side pushing it slightly sideways. But there's still no coma, no dust, and no trace of venting gases. Spectroscopic data remains flat. The object isn't burning or bleeding any material, it's moving cleanly, deliberately, with a precision that no natural body could maintain unaided. NASA's Deep Space Navigation team ran a backpropagation simulation to test possible causes. The program found that if even a microthrust equivalent to 1 gram of force were applied continuously over the last 72 hours, it could create the observed trajectory shift. That's about the force generated by a feather pressing against your hand, but in space, sustained over distance, it's enough to alter orbits. The unsettling part is that there's no mechanism visible to generate it. This realization has triggered quiet, but serious conversations across multiple agencies. If 3I Atlas is generating thrust, the question isn't how, it's why. Is it stabilizing its flight path, adjusting its attitude, or heading towards something? The current trajectory now passes close to a gravitational corridor that intersects the orbit of Earth in several months. It's not an impact path, not even remotely close, but the alignment is precise enough to raise eyebrows. Objects drifting freely don't align with orbital corridors by accident. ESA's Near-Earth Object Coordination Center has begun to model future positions under various assumptions. If the vector shift continues at the same rate, the object will exit the Sun's influence in a new trajectory angled just 12 degrees from the Earth-Sun line. That's close enough for radar mapping, but far too close for comfort in terms of coincidence. Meanwhile, the object's radio emissions, the spectral noise first detected in the last chapter, are changing subtly in sync with the trajectory drift. The 6-minute pulse remains, but its harmonic tones have begun to stretch and compress as if responding to the shift in motion. It's as though the signal itself is adjusting with the movement, staying calibrated to some internal reference frame. Physicists are calling this vector-locked modulation. In simpler terms, the radio pulse now seems tied to the object's course. When it changes direction, the signal changes frequency, always in sync, always stable. That correlation can't be random. It implies a closed feedback loop, motion influencing transmission, and transmission influencing motion. At the Harvard Center for Astrophysics, a closed-door meeting discussed this possibility in cautious terms. One senior researcher described it like this: if you had a self-navigating system trying to stay within a certain corridor, this is exactly what its data would look like. The implication was left unsaid. 3I Atlas may be following instructions, not physics. Outside of academic circles, the tone is more restrained. NASA has released a brief statement citing minor non-gravitational accelerations under review. no mention of alignment with the ecliptic plane, and no comment on the hydrogen line emissions. But the scientists monitoring the numbers see the pattern forming, a slow, continuous vector realignment that looks less like drift and more like a maneuver. Independent analysts have also noticed a small but telling change in the object's apparent velocity. Its radial speed, motion relative to the Sun, has decreased by roughly 0.3% since perihelion. That might not sound like much, but slowing down in the Sun's gravitational field requires active counterforce. Natural objects accelerate as they fall inward and decelerate passively as they escape. 3I Atlas's deceleration is too smooth, too controlled. It's as if it's pacing itself, matching velocity to a planned outbound route. In a rare move, ESA's flight dynamics team shared limited data with external astrophysicists under confidentiality agreements. What they revealed privately is that the curve of 3I Atlas's new trajectory intersects multiple zones where solar magnetic field lines converge, regions of high plasma density and low radiation pressure. These areas are known as quiet corridors, paths where interference is minimal. A spacecraft travelling through them would experience fewer disturbances. It's speculation, but it fits. The vector shift isn't random, it's efficient. One researcher from JPL described it plainly during a midnight session. It's like watching a sailboat tack into the wind. Every motion has a purpose. As of this hour, 3I Atlas continues along that new path, drifting with elegance through the heliospheric current sheet. The course change is gradual but constant. If the acceleration holds, the object will cross the solar equator in roughly 10 days. A move no comet or asteroid has ever made this cleanly. We still don't know what's driving it, or if the motion is even active. But the growing alignment between trajectory, rotation, and radio pulse paints a picture of structure, not chaos. And deep down, every analyst reading those numbers feels the same quiet realization building. Whatever 3I Atlas is doing out there, it's doing it with intent. By the time the vector data reached public databases, the astronomy community had already fractured into two camps. One side sees the unfolding data as a cascade of coincidences. Strange, but still within the boundaries of physics. The other side believes those boundaries may no longer apply. What began as a simple tracking anomaly has now become a global argument about what 3I Atlas really is and what it means for science if the behaviour we're seeing can't be explained naturally. The cautious group, the traditionalists, insist on restraint. They argue that non-gravitational acceleration isn't new. Oumuamua showed a similar effect back in 2017, they remind everyone. The key difference, they claim, is measurement sensitivity. Today's instruments are far more precise, and the small deviations now being labelled unnatural would have gone unnoticed decades ago. According to them, the simplest explanation remains correct. Residual outgassing from beneath the surface is pushing the object subtly off course. The lack of visible dust doesn't prove the absence of material, it just means our sensors can't resolve the particles. But that logic is wearing thin. After nearly 2 weeks of non-stop observation, not a single trace of gas, plasma or debris has been detected. Spectrometers show a flat line where volatile emissions should appear. The optical transparency around the object remains absolute. Even those clinging to the natural model are running out of parameters to tweak. One researcher at the University of Tokyo put it bluntly, "We've exhausted every natural cause we can model, and it's still accelerating." The opposing camp, the ones willing to entertain the unconventional, are careful with their words but not with their conviction. They describe the situation as a behavioural anomaly, a term rarely used in astrophysics. To them, 3I Atlas is exhibiting coordinated responses, patterns too synchronous to emerge from randomness. The alignment between its rotation, radio emissions and trajectory shift suggests feedback, an exchange between internal and external forces. In essence, a kind of decision-making. Between those two extremes lies the uneasy middle. Scientists who don't believe in anything extraordinary, but can no longer defend the ordinary either. In late-night discussions across university networks, a single theme repeats. We're running out of analogies. The data looks engineered, but saying so out loud would ignite controversy that could end careers. The debates have spilled beyond academia. News outlets have begun publishing leaks from observatories, often exaggerated or misinterpreted. Headlines speak of intelligent maneuvers and controlled rotation. forcing agencies to release public statements denying any evidence of artificial behaviour. Yet those same agencies continue to classify parts of the data, especially the hydrogen line radio bursts, under restricted access. The contradiction only deepens public curiosity. Inside NASA, a memo circulated earlier this morning summarising the official position. Current observations indicate non-gravitational acceleration, consistent with previously observed interstellar bodies. No evidence of technological activity is confirmed. That last word, confirmed, is doing most of the work. It leaves open everything that hasn't yet been ruled out. Meanwhile, in Europe, the tone is shifting. ESA's Planetary Science Division quietly issued a report acknowledging that 3i Atlas exhibits unexplained stability across multiple parameters, an unprecedented phrase for an official document. One line, later redacted in public release, reads, "The coordination of optical, thermal and radio signatures cannot be replicated in current cometry models." Scientists who contributed to that report say privately that the phrase "cannot be replicated" was chosen carefully. It doesn't mean impossible, it means no simulation, no matter how complex, has reproduced what 3i Atlas is doing. Among those watching from the sidelines, the debate is no longer purely academic. Philosophers, physicists, even theologians have begun weighing in. Some call it a wake-up call, a reminder that humanity's grasp of celestial mechanics might be incomplete. Others fear it could reignite old myths about visitors and watchers. For the professionals analysing raw data, though, the tone is pragmatic. They're less concerned with meaning and more with verification. Every conclusion demands replication, and so far no instrument disagrees. Still, skeptics have valid points. Space is full of oddities that defy expectation. Radiation pressure, micrometeoroid impacts, even subtle instrument errors can create illusions of precision. Extraordinary claims need extraordinary proof, and that proof doesn't exist yet. The problem is that each new data set pushes the natural explanation further out of reach. The breaking point came when a collaborative model between Caltech and the European Southern Observatory tried to reproduce the vector shift using every known physical factor. The simulation failed repeatedly, unless they added a controlled force acting in the direction of travel, constant and sustained. When they did, the model fit perfectly. The only question was what to call that force. They settled on persistent thrust. Those two words spread like wildfire across internal emails and online forums. Persistent thrust became shorthand for everything that's wrong with the official story. A natural object can't maintain continuous acceleration without fuel or outgassing. Whatever 3i Atlas is doing, it's not coasting. That realization hasn't united scientists, it's divided them further. Conferences once devoted to planetary science are now hosting impromptu sessions on interstellar engineering, magnetic propulsion, and field-based acceleration. None of these theories are proven, but their very existence shows how far the conversation has shifted. What began as a small deviation in trajectory has become a challenge to the foundation of celestial mechanics. Behind the scenes, agencies are cautious. The language in their communications is deliberately neutral: monitoring, analysis ongoing, further data required. Yet the number of restricted datasets continues to rise, especially those dealing with the synchronization between radio emissions and vector drift. Every new restriction adds fuel to speculation. The situation has become a paradox of transparency. The more data is released, the less anyone seems to understand. And while the arguments continue, 3i Atlas keeps moving. Quiet, stable, unwavering. It doesn't wobble, it doesn't erode, it doesn't flicker. Whatever this object is, it isn't waiting for us to agree on what it means. For now, the debate remains human. The behaviour we're witnessing does not. At first, no one believed the images. They came from an amateur astronomer in Chile using a modified deep sky tracking rig, who noticed faint streaks trailing near 3i Atlas's latest coordinates. He assumed it was noise, camera artifacts or cosmic rays hitting the sensor. But when he sent the raw files to a colleague in Australia, she found the same faint shapes in her own data captured hours apart. Both images showed two small dim points following the same vector as 3i Atlas, maintaining identical velocity and distance. When professional observatories turned their instruments toward the region, the pattern held. Two secondary objects, faint, silent and consistent, were visible in long exposure frames. The distances between them and the main body remained constant to within a few kilometers, despite their independent motion through a turbulent solar wind environment. That kind of formation isn't normal. In orbital mechanics, independent masses should drift apart rapidly under the slightest perturbation. Yet these did not. The discovery was confirmed by the Very Large Telescope in Chile and corroborated by radar signatures from the Deep Space Network. The two secondary echoes appeared at exactly the same relative positions. In effect, 3i Atlas was no longer alone. For days, agencies avoided acknowledging the finding publicly. The data was filed under anomalous reflections and quietly removed from open access feeds. But too many observatories had seen it. By the time the International Astronomical Union convened an emergency working group, the news had already spread through encrypted astrophysics channels. Astronomers began referring to the new objects informally as Atlas B and Atlas C. What stands out most is their motion. Both objects mirror 3i Atlas's rotation cycle, 6 hours, perfectly synchronized. Even their spectral brightness oscillates in phase with the main body's light curve. The implication is staggering. 3 distinct objects separated by tens of kilometers, maintaining identical rotation and modulation in perfect sync. There's no natural mechanism to coordinate that behavior across separate bodies without some kind of link. Scientists are scrambling to understand the connection. Some hypothesize that 3i Atlas fragmented during perihelion, and the smaller pieces happen to share the same momentum, but that theory collapses immediately. The secondary bodies aren't fragments, they're intact, symmetrical and smooth. Their radar cross-sections show uniform reflectivity, suggesting stable structure, not debris. And unlike fragments, they show no divergence. Their trajectories remain parallel, as if tethered by invisible lines. ESA's optical tracking team proposed that the objects might be caught within a shared electromagnetic field generated by the main body. That could theoretically trap smaller metallic companions in a formation orbit, though no such naturally occurring fields have ever been recorded at this scale. Others argue that it's a visual illusion, bright reflections of solar light off unseen plasma filaments connecting them, but that explanation doesn't fit the radar data. The echoes are solid. A more speculative idea has emerged quietly among the scientists who first noticed the synchronization. If 3i Atlas is not a single body, but part of a coordinated system, these companions could serve a function, like modules or probes operating in tandem. The arrangement recalls swarm configurations used in advanced satellite arrays, where multiple autonomous units share orientation and timing through a common signal. In that scenario, the hydrogen line emissions detected earlier might not be random at all. They could be synchronization pulses maintaining communication between units. One particularly striking piece of evidence came from the radio observatory in La Palma. While analysing the hydrogen line emissions, researchers noticed faint echo signatures repeating a few seconds after each primary burst, echoes that arrived at intervals corresponding exactly to the distances between 3i Atlas and the two secondary bodies. That's not propagation delay through space, that's bounce-back timing. In other words, the smaller objects may be reflecting or retransmitting the main signal. If that's true, it means coordination. Inside NASA's Jet Propulsion Laboratory, the discovery has caused quiet panic. Engineers are now tasked with finding any known natural process that could replicate such precision. So far, there are none. Gravitational resonance, electromagnetic capture, and plasma coupling all fail under simulation. The synchronization remains absolute. Privately, scientists are beginning to describe the configuration as a formation network. It's not an official term, but it fits what's being seen. One central mass, 2 accompanying nodes, all sharing orientation, light modulation, and motion. The pattern repeats across multiple observation cycles, unaffected by solar radiation pressure, magnetic drag, or orbital noise. The implications are enormous. If the formation is stable, it means 3i Atlas can project influence beyond its physical boundaries. That could suggest a collective mechanism, a system capable of extending control over smaller objects. The analogy often used in closed meetings is distributed architecture. Each unit might perform a different task: measurement, communication, stabilization. Skeptics point out that this sounds far too advanced to consider seriously, but those same skeptics struggle to explain the precision of the alignment. The odds of 3 independent bodies maintaining perfect phase lock through random chance are estimated at less than 1 in 10 trillion. Despite the mounting evidence, official channels remain silent. Publicly, the discovery of Atlas B and Atlas C has not been confirmed, but several research teams have released anonymized data that anyone can verify. The formation exists, and it's moving together as one. One astronomer from the European Southern Observatory, speaking anonymously, summarized it quietly during a private session. If these objects were fragments, they'd be dispersing. If they were natural satellites, they'd be orbiting. But they're doing neither. They're following. That single word, following, now appears in reports from every observatory still tracking the event. As of now, the three bodies continue on the same vector, maintaining their perfect 6-hour cycle, their synchronized pulses and their fixed geometry. Whatever invisible structure binds them, it's holding strong. His signals stopped at 2:14 UTC. For nearly 2 weeks, observatories around the world had grown accustomed to the quiet rhythm coming from 3i Atlas, the steady, hydrogen-line pulse that rose and fell like a cosmic metronome. Then, without warning, the rhythm broke. The next pulse didn't arrive. Neither did the one after that. Within 6 minutes, every array pointed at the coordinates of 3i Atlas reported the same thing. Nothing. Not noise, not distortion, just absence. At first, it was dismissed as a temporary loss of lock. The object had been faint before, and interference from the solar wind often masks weak signals. But when optical tracking teams checked their images, the problem deepened. 3i Atlas wasn't just silent, it was gone. Every instrument that should have seen it, the Very Large Telescope, Subaru, Mauna Kea, and ESA's spaceborne probes, reported an identical failure to reacquire the target. Even radar couldn't find it. The last confirmed reflection from the Deep Space Network came at 2:13:57, just 17 seconds before the first missed pulse. After that, all returns vanished. For hours, the astronomy community scrambled to explain what happened. Some blamed sensor errors, others proposed interference from a solar flare. But space weather readings showed no anomalies. There was no flare, no plasma surge, no instrument malfunction. The object simply dropped below every detection threshold at the same moment across the planet. The most unsettling detail wasn't the disappearance itself, it was how cleanly it happened. Natural bodies fade gradually as they move out of view or dim behind solar interference. This wasn't gradual, it was instantaneous, as if someone flipped a switch. Within hours, agencies coordinated emergency sweeps using infrared and radio telescopes in multiple wavelengths. The result was identical. No return, no echo, no trace. 3i Atlas, along with its 2 companion objects, had ceased all detectable activity. In the data archives, the last recorded pulse carries a faint irregularity, a small uptick in amplitude followed by an abrupt cut. The pattern looks like a transmission cutoff rather than a decay. It ends mid-cycle, the waveform sliced in half. That precision is almost impossible for a passive natural process. In the absence of data, theories multiply. Some claim that 3i Atlas simply rotated into an angle that reflects light and radio signals away from Earth. Others believe it passed into a region of magnetic interference strong enough to obscure its emissions. But every alternative faces the same problem. There's no corresponding effect on nearby spacecraft or solar observatories. The space around the coordinates is calm and transparent. Then, new reports began arriving from secondary observatories, faint whispers of something at the edge of detection. Instruments in South Africa and New Mexico picked up a diffuse signature, offset by a few degrees from the original path. It wasn't strong enough to confirm, but the timing matched exactly 3 rotation cycles after the silence began. If this signal is real, it suggests 3i Atlas moved, not drifted, jumped. Trajectory analysts ran the numbers. The apparent offset, if genuine, represents a displacement of nearly 50,000 kilometers in less than 18 minutes. That kind of motion would require instantaneous acceleration, far beyond any known physical limit. No comet, asteroid or fragment could achieve it without disintegrating. NASA's official report calls it unverified positional data, but privately, the term being whispered across networks is phase transit. In essence, it's the idea that the object didn't disappear, it transitioned. The more grounded explanation, favoured by cautious researchers, is a coordinated failure. They suggest that 3i Atlas might have emitted a burst of electromagnetic interference strong enough to blind our instruments temporarily. If that's true, the blackout would be artificial, a deliberate act to hide itself. Others propose that it's not interference at all, but adaptation. Throughout its journey, the object has changed, dimming, cooling, synchronizing. If those behaviors were preparation, the silence could mark a new phase in its operation. It's possible that it's conserving energy, shielding itself, or entering a dormant state now that perihelion is behind it. But that theory collides with one fact that no one can ignore. The object didn't fade when it moved away from the sun. It brightened. It was most active when closest to detection. Its sudden disappearance doesn't fit a dormancy model. It fits something else, controlled withdrawal. Behind closed doors, teams from ESA, NASA and Harvard are comparing notes. Several classified instruments, ones not usually discussed publicly, have also lost contact. Deep space radiometers, magnetometers, and high-sensitivity gamma detectors all show the same pattern, a sharp drop to zero at the exact same second. That suggests synchronization, not coincidence. The silence isn't local, it's global. As of now, all attempts to re-establish contact have failed. The arrays continue listening, sweeping through every possible frequency band. Nothing responds. But just before the blackout, the La Palma Observatory recorded something strange. A faint transient signal embedded in the final pulse. It lasted less than a second but carried a distinct frequency sweep that looked deliberate, like a closing tone. Analysts who've examined it describe it as an end signature, a pattern used in engineered systems to mark a completed sequence. If that interpretation is correct, 3i Atlas didn't vanish accidentally. It completed a process. Officially, the disappearance will be described as temporary loss of tracking. Privately, few scientists believe it will return to visibility in the same way. The phrase used most often in the internal notes isn't disappearance, it's disengagement. And now, for the first time since its discovery, every screen monitoring the coordinates of 3i Atlas is blank. The object that survived the sun, resisted erosion, and defied physics has gone silent, leaving only static and unanswered questions behind. If the leak began quietly, passed through an encrypted academic network and eventually landing in the inboxes of a few senior astrophysicists who were not supposed to see it. The document, marked internal draft, not for distribution, originated from a small working group at the Harvard-Smithsonian Center for Astrophysics. Within hours, it was being discussed in late-night calls across 3 continents. Its contents were never meant for the public, but the phrasing inside is what has frozen the community. The memo doesn't confirm anything sensational. There's no mention of extraterrestrial design or intelligent control. What it does contain, though, is worse. A quiet acknowledgement that current astrophysical models cannot explain the last month of observations. It begins with a simple sentence. The post-perihelion activity of Object 3 Atlas exhibits behavioral coherence inconsistent with inert celestial dynamics. Behavioral coherence. Those 2 words now hang over every scientific conversation. In essence, the team is admitting that 3i Atlas acts with coordination. The report outlines 15 pages of anomalies: synchronized rotation, thermal inversion, controlled vector drift, harmonic radio emissions, and the simultaneous silence of multiple instruments. Each event is treated as a discrete mystery, but together they describe a pattern that no one can reproduce mathematically. According to the memo, every conventional explanation has been tested and discarded. Outgassing, radiation pressure, magnetic capture, data contamination, all fail under simulation. The conclusion is unsettlingly neutral. No known physical process accounts for the coordination of observed variables. It doesn't say unnatural, it doesn't have to. The tone throughout is clinical, almost detached. Yet between the lines there's clear unease. The authors admit that certain readings, particularly the final hydrogen line pulse, display frequency compression consistent with information encoding. That sentence buried on page 7 has now become the focus of intense debate. Was 3i Atlas sending data before it disappeared? And if so, to whom? Several key details in the memo contradict the public narrative. It confirms that the object's disappearance wasn't simultaneous across all sensors. Infrared and radar arrays lost contact within the same 30-second window, but 2 optical telescopes in different hemispheres registered faint transient light at slightly offset positions. That suggests motion, not extinction. The object didn't blink out everywhere at once. It shifted subtly but intentionally out of direct line of sight. Another section, labelled Confidential Observational Summary, references data from the Hubble Space Telescope that has not been released. Those frames reportedly captured structural luminosity variants, in simpler terms, sections of the object brightening independently like panels adjusting or folding. The memo stops short of interpretation, but its phrasing implies transformation rather than disintegration. Buried deeper is a table comparing the timing of 3I Atlas's final emissions with historical data from deep space radio archives. Two entries stand out: the 1977 WOW signal and an unexplained hydrogen band anomaly detected in 1996. The memo doesn't claim a connection, but the correlation is uncanny. The frequency offset between those events and 3I Atlas's last emission is within 1 part per billion, essentially identical. That realization has led some researchers to a chilling possibility. We may have been hearing fragments of the same source for decades without realizing it. The memo closes with a paragraph written in cautious bureaucratic language, but the meaning is unmistakable. It recommends temporary data retention embargo and interagency consultation regarding coordinated communication anomalies. In other words, they want to pause public access to any data connected to 3I Atlas until the implications are fully understood. Unofficially, that embargo has already begun. Data streams that were once public have gone dark. Amateur astronomers are finding that coordinates once visible through online telescopes are now restricted. Requests for radar tracking times are quietly denied. The story is closing in on itself, sealed under layers of scientific discretion and national security. Still, not everyone is staying silent. A few of the memo's recipients have spoken anonymously, confirming its existence without revealing full content. One of them, a systems physicist at MIT, described the document as a reluctant admission. He said, "They're not calling it a spacecraft, but they are saying it behaved like one. Inside research circles, the leak has split scientists even further. Some argue it's a draft taken out of context, that phrases like behavioral coherence are academic shorthand for complex data correlations. Others point out that no one from Harvard has denied the document's authenticity. The usual damage control statements, misinterpretation, incomplete data, premature conclusions, have not been issued. Only silence, and that silence is louder than denial. Right now, behind closed doors, agencies are re-examining every interstellar object ever recorded, checking for overlooked irregularities, slight non-gravitational drifts, unexplained emissions, spectral echoes. For the first time, they're treating them not as curiosities, but as potential precursors. The Harvard memo ends with a single line, centered and italicized. Further monitoring recommended upon re-emergence. Re-emergence. The word implies expectation, not if, but when. Whether 3I Atlas has truly vanished or merely slipped behind some invisible curtain, the people who wrote that memo seem convinced it isn't gone for good. And somewhere, in the silence between those missing pulses, they're still listening. Is the end of observation? It ended on its own terms. Inside the research community, the phrase everyone once whispered has now entered quiet discussion, the artificial hypothesis. No one announces it officially, yet everyone knows it's there, the unspoken conclusion hanging above every meeting, every data set, every attempt to explain the unexplainable. For months, scientists have watched 3I Atlas behave in ways that seem too precise for nature. It cools when it should burn, steadies when it should tumble, adjusts its course without visible cause, and disappears with timing so exact it feels rehearsed. Step by step, the evidence no longer describes an object merely surviving its journey through the solar system. It describes an entity performing through it. The term first appeared in a closed session at the Kavli Institute, when one researcher summarized the growing unease with a single line, "We are observing control." The room went silent. Not because the statement was sensational, but because it finally matched what everyone saw in the numbers. Across hundreds of independent instruments, the data reveals behavior that fits no model of random physics. The rotation lock, the synchronized companions, the modulation of light, the spectral pulses, all follow a sequence, each responding to the last-like stages in an engineered system test. No chaotic drift, no breakdown, only reaction, adaptation, and progression. Skeptics still argue for natural causes, but their explanations are thinning. Outgassing cannot produce precise 6-hour synchronization. Magnetic interaction cannot sustain a perfect rotational lock, and no known mineral composition explains temperature drops under solar radiation. Every time a new dataset arrives, it contradicts the very model meant to justify it. What remains is coherence, a kind of order that doesn't belong to coincidence. The shift in tone within observatories is subtle but unmistakable. Scientists who once spoke of non-gravitational acceleration now talk about guidance. Those who blamed outgassing now describe vector management. Even the language has started to change. One NASA engineer reviewing the data said it quietly during a late-night call, "If this were human, we'd call it navigation." Parallel analyses from independent research teams have reached similar conclusions. When the hydrogen line pulses are cleaned of background noise and plotted against the object's motion, the signal changes frequency in sync with each adjustment in its trajectory. That kind of coordination implies feedback, a real-time connection between movement and emission. On Earth, that's telemetry. This realization has forced scientists to cross a line they were never trained to cross, the boundary between physics and intention. No one claims to understand what 3i Atlas is, or who, if anyone, built it. The discussion isn't about origin, it's about function. If the data were describing a spacecraft test here on Earth, no one would hesitate to call it an operational cycle. Solar approach, energy absorption, cooling, stabilization, course correction, signal output, then silence. The artificial hypothesis doesn't claim communication or intelligence. It simply acknowledges the unmistakable presence of structure, a set of actions with internal logic. Nature can imitate design through coincidence once, maybe twice, but not across months, not across multiple instruments, not through every measurable wavelength. Privately, a few of the scientists closest to the project have begun to speak in language that borders on reverence. They describe 3i Atlas not as a machine, but as a system, a self-regulating organism of metal and geometry, guided by rules we haven't yet written down. One astrophysicist described it in her notes as a process unfolding according to intentions older than our vocabulary. And perhaps that's why the tone surrounding the research has grown quieter, almost respectful. There is no declaration, no discovery press conference, no proof. Only a shared understanding spreading among the people who have stared longest at the data. That this object is not behaving like a passenger of gravity, but like a participant in its own story. The artificial hypothesis remains unofficial, but inside those sealed laboratories and data centers, belief has already shifted. The scientists still call it a hypothesis only because science requires them to. But when they speak off record, their words carry a different certainty, not of knowing what it is, but of knowing what it's not. 3i Atlas has stopped being a mystery of physics. It has become a question of design. For weeks, researchers have stared at the same data streams, each trying to find order in the noise. Every wavelength, every pulse, every trajectory plot has been dissected, inverted, filtered, and reassembled. What began as a search for understanding has slowly become something stranger, a realization that the patterns aren't just there by coincidence. They're deliberate, and more than that, they're consistent across every layer of observation. The turning point came when a cross-disciplinary team at Caltech overlaid 3 separate datasets: optical brightness curves, radio pulse intervals, and thermal flux measurements. On paper, they have nothing to do with each other. Yet, when aligned by timestamp, the 3 signals form a single repeating pattern, a rising and falling sequence that mirrors the Fibonacci progression. At first, no one wanted to believe it. Data coincidence happens, but the ratio held perfectly for 12 consecutive cycles, the same mathematical structure that governs spirals in galaxies' shells and DNA. No one is claiming communication, but to the people staring at those numbers, it feels as though the object is following a rule, one that balances complexity with elegance, order with entropy, a rule that feels chosen. Further analysis revealed something even more unnerving. The interval spacing between the radio pulses, when converted to logarithmic frequency and plotted as a tone sequence, forms harmonic ratios almost identical to those used in human musical scales. The correlation is so close that, when the signal is rendered into sound, it produces a soft rhythmic resonance. Not noise, not static, but structure. Some call it coincidence, others call it architecture. At the SETI Institute, a team working independently discovered that the thermal pulses recorded before the blackout align with geometric relationships found in the object's shape models. Each hotspot appears at distances proportional to the golden ratio, repeating along its elongated frame like an internal code etched into its design. That level of proportionality doesn't occur randomly in nature. It's not proof of intent, but it is proof of precision. For the scientist analysing this, the question has shifted. It's no longer whether 3I Atlas is natural or artificial, it's whether its behaviour is the result of randomness or memory. Because the more they compare these datasets, the clearer it becomes that the object isn't just reacting to forces around it, it's following instructions embedded within itself. The resemblance to engineered systems is uncanny. When spacecraft undergo internal diagnostics, they output patterns, sequences of controlled signals to verify synchronization between subsystems. Those patterns often use simple mathematical structures because they're efficient, universal, and error-resistant. What 3I Atlas has shown since Perihelion, a consistent 6-hour cycle, harmonic radio emissions, geometrically aligned heat nodes, matches that logic almost perfectly. It's not proof of construction, but it's evidence of organization. And then one more discovery, one that reframed everything. While comparing old radio records, a data analyst at the University of Bologna noticed a faint echo of the same hydrogen line modulation buried deep in a 1977 dataset, the WOW signal. The frequencies aren't just similar, they're nearly identical, down to 5 decimal places. For decades, the WOW signal was considered an isolated event, a blip of cosmic noise. But if this correlation holds, it suggests the same modulation signature has appeared twice, once 48 years ago, and again now, coinciding with 3I Atlas's approach. The pattern may not be communication, but it might be continuity, a repeated structure passing through different eras, as if something is checking in on its own trajectory across time. In internal briefings, researchers now talk about systemic behaviour, the idea that 3I Atlas is part of a recurring mechanism, one that awakens only under specific cosmic conditions. The data implies awareness of environment, not consciousness in the human sense, but responsiveness, the kind seen in autonomous systems executing long-range instructions. What unsettles many isn't the possibility that it's a machine, but that it's behaving with restraint. Everything about it suggests purpose without aggression, calibration, observation, silence. No attempt at contact, no interference, only motion and pattern. The recognition spreading quietly among scientists isn't fear, but humility. The realization that something out there operates with a precision that predates us. A process capable of navigating cosmic distances, interacting with stars and regulating itself without decay. A system that understands balance better than we do. No one knows what comes next. Some believe the silence will last for decades before it reactivates. Others think the signal hasn't stopped at all, that it's simply moved to a frequency we haven't learned to hear yet. But one thing is certain now. The data we once called anomalies are no longer random. They belong to a structure, a design, a pattern woven into the mechanics of space itself. And when you step back far enough, that pattern begins to look less like a mystery and more like a signature. The most recent orbital solutions have upended everything we thought 3I Atlas was doing. When the object first emerged from behind the Sun, its path suggested an outbound escape, a clean hyperbolic arc carrying it back into interstellar space. But after weeks of refined tracking and recalibration, the numbers now tell a different story. The trajectory isn't carrying it away. It's flattening, bending subtly, predictably, toward the ecliptic plane. The object is not leaving, it's adjusting course toward us. No one is saying that out loud in public briefings, but that's the implication written between every line of the internal reports. The same analysts who confirmed the vector drift weeks ago now see the curvature forming a new intersection point. If the shift continues at the same rate, 3I Atlas will align with Earth's orbital path within the next several months. Not on a collision course. The separation remains vast, but close enough that its motion can no longer be described as random. It's heading toward the inner system on purpose. At the European Space Operations Centre, teams are recalculating every model under controlled secrecy. The changes are small, almost imperceptible on the daily graphs, but consistent. Each day, the object's position advances along an adjusted bearing that points increasingly close to Earth's orbit. The most conservative models suggest a near approach of several million kilometres, distant enough for safety, close enough for direct observation. The problem is that this new trajectory requires energy. Gravity alone cannot produce it. The last fragments of data received before the disappearance hinted that 3I Atlas was decelerating as though preparing for something. When it vanished from sensors, some assumed it had gone dormant. Now, the curve of its return suggests it never stopped moving. It simply changed phase, invisible to our instruments while continuing to alter its path. That interpretation fits the data too perfectly to ignore. Astronomers studying the orbital plane have noticed something else. The object's projected intersection point lies near a quiet corridor, a region of gravitational equilibrium between Earth and the Sun, a place often used for satellites and observation probes. It's stable, predictable, and shielded from solar interference. To engineers, it's a perfect parking orbit. To astrophysicists, it's an eerie coincidence. Inside mission planning rooms, questions multiply. If this is natural, what kind of interstellar debris could execute such precision without disintegrating? And if it isn't natural, then what is the next stage? There's a growing belief that the current trajectory isn't its final one, that 3I Atlas is adjusting gradually, performing incremental course corrections to disguise its true target until the last possible moment. Each movement is small enough to look organic, but when extrapolated together, the pattern emerges clearly. It's steering toward the inner planets. Satellite networks have been repurposed to keep watch. Military radar systems, space-based infrared telescopes, even instruments not designed for deep space tracking have been assigned to monitor the corridor where 3I Atlas may reappear. Yet so far, nothing. The silence continues. Some scientists believe it's already there, hidden behind the noise of the sun's electromagnetic field. Others think it's still on approach, invisible because it's adapted again. Its thermal emissions fully cloaked, its reflectivity tuned below detection thresholds. If that's true, the next time we see it might not be from distant telescopes, but from local instruments, the ones orbiting Earth. The scenario sounds like science fiction, but every day the equations push closer toward that possibility. Even small corrections in its path place it on an inevitable curve toward the same region occupied by human observation satellites. The agencies involved have started preparing quietly. Plans are being drafted under code names: high-sensitivity radar tests, expanded radio frequency sweeps, reactivation of dormant space surveillance systems. Officially, these are precautionary measures to enhance early detection of non-gravitational anomalies. Unofficially, they are preparations for the moment the object becomes visible again, closer, clearer, and perhaps more active than before. The psychological impact among scientists is growing. The debate between natural and artificial is fading, replaced by something heavier, a quiet acceptance that they might soon have to face it not as data, but as presence. One senior astronomer in a late-night call described the mood as a mix of awe and dread, the sense that humanity may be about to witness something it cannot categorize without redefining its own place in the cosmos. For now, the official line remains cautious. No confirmation of artificiality, no statement about the new trajectory. But behind the scenes, every major observatory has its instruments locked onto the same coordinates, waiting for the first flicker of light or the faintest radio whisper to break the silence. If 3I Atlas truly is returning to the inner solar system, then the question has shifted once again. It's no longer what it is or how it works. It's why. Why now, after millions of years of silence? Why aim for a corridor filled with our machines, our sensors, our eyes? Somewhere out there, between the gravity of the sun and the thin electromagnetic shell surrounding our planet, a shadow is moving in perfect silence. It's following a path no one expected, one that feels less like escape and more like arrival. And as every model points closer to the same conclusion, a new understanding begins to take hold among those still tracking it in secret. 3I Atlas was never just passing through, it was coming here. Across the world, the screens once filled with numbers are now still. Tracking interfaces, spectral monitors, radio arrays, all waiting, all listening. Somewhere beyond the reach of our detection, an object that should no longer exist is completing a curve that no one can see but everyone can feel. 3I Atlas, once thought to be on its way out of the solar system, is turning homeward. For months, we've tried to fit its behaviour into the language of physics: thrust, drag, flux, drift. But each new dataset only widened the gap between what should be possible and what we're watching unfold. It stabilised rotation that should have been chaotic. It cooled where it should have burned. It created a formation when isolation was the rule. And when observation became too close, it silenced every instrument, as if the act of being seen violated its design. Now the models all point toward a single inevitable conclusion. Whether by inertia or intention, its path brings it back toward us. The calculations aren't speculative anymore, they converge. The same invisible mathematics that once carried it through the sun's gravity is now guiding it toward the thin orbital corridor where our satellites float. We don't know when or where it will reappear, only that when it does, it will no longer be a distant mystery, but a local presence. Inside the research centres that still dare to talk about it, the tone has changed. The excitement that once surrounded its discovery has given way to quiet recognition. The scientists who followed it from the beginning don't call it an anomaly anymore, they call it the system. To them, 3I Atlas is no longer an object. It's an event, one that has unfolded with precision from the moment it entered our instrument's reach. Some believe it was never meant to communicate, only to observe, a mechanism older than our civilization, reawakening at intervals we don't yet understand. Others think the silence is part of its protocol, a pause before the next stage of operation begins. Either way, what began as curiosity has become something larger. We're no longer just watching it, we're inside its orbit, part of the geometry it draws through space. The public may never know how much of the story is true, the leaks, the data, the silence. They blur together now into something that feels more like rumour than science. But those who have seen the real numbers understand that this isn't myth, it's measurement. And measurement doesn't lie. If it reappears, the telescopes will find it again, the radio dishes will wake and the silence will break, not with noise, but with rhythm. The same 6-hour cycle, the same pulse, perhaps adjusted, perhaps transformed, the same signal that once rose out of the background of the universe, faint but deliberate, will return. Until then, all we can do is wait. The data ends, the models flatten, the sky goes quiet, but the line of motion, the return arc, continues unseen, bending through darkness exact and inevitable. Somewhere beyond the reach of light, 3I Atlas is still moving, carrying its silence with purpose. And when that silence finally ends, the question we've been asking for months, what is it, will no longer matter. Because by then, we'll understand that it was never just passing through. It was always coming back.